Question 1, finding the gradient of the curve represented by y equal 2x squared minus 8x plus 2 at that point. So because they ask you to find the gradient of the curve and you are doing a differentiation, a calculus paper, then the first step is you differentiate to find the equation of the gradient. So it's y dash equal differentiate 4x minus 8. Your next step is substitute the 1 or the x value into the differentiation equation. So it's m equal 4 times 1 minus 8, and the answer is -4. So the gradient of the curve is -4 at the point 1, -4. Next questions is differentiate the function fx 1 equal 1 over x squared. So the first thing is you rewrite x as in to the numerator, move it to the numerator, so it's become -2x, and then you differentiate it as you differentiate a polynomial. So -2 to multiply by the power, and then x to the power of -2 minus 1, take 1 from the power, so it's become -3, and the answer will be -2 over x to the power of 3. You notice that I've returned it back into the denominator as the question is given in the denominator. This question here, they say use the second derivative test to find the nature of the turning points. So the first thing, as it says here, nature of turning points, and it's giving you the equation. So the first step you would do is differentiate. So I would expand first, because you can't differentiate rule. So you'll expand. I'll expand the first two brackets first, and that's give me x squared plus 5x plus 6 close bracket, and then that third bracket left, and now keep expanding. So you'll notice I've written fx because I have not differentiated yet. I'm just expanding, plus 5x squared plus 6x minus 2x squared minus 10x minus 12. Then simplify, so I'm keep writing f to x. Now simplify, I end up with x to the power of 3 plus 3x squared, collecting the like terms, minus 12. Now I'll start differentiating, because to find the turning points I will differentiate, make it equal to 0. So I'll differentiate that. 3x squared for the first term, second term is 6x minus 4. Now to find the nature of the turning point, I make the differentiation equal to 0. Solve, you can use your graphic calculator. So if you use the graphic calculator, you go to menu, equation, and then press F2 for polynomial, then F1 for the degree of 2, and just entered A, 3 for A, positive 6 for B, and C is -4. Press solve, and you'll get those two values. So the first value is x equal 0.53. Second value is -2.53. Now, after I found the turning points, I need to find the nature of the turning points. And it says here in particular, you have to use the second derivative test, which is this one here. So because the second derivative, you have to double differentiate now your function. So double differentiate, we'll come to this one here, we'll differentiate. 3x squared differentiate is 6x plus 6. Now to substitute, so you will take the point that you've chosen. So the first one is 5.3, 0.53 equal, I will substitute it in the double differentiate function. And the answer I get is 9.18, which is greater than 0, which means, according to this rule in here, that's been already given to you, if it is greater than 0, then it is a minimum point. So that means, so x equal 0.53, my turning points, is a minimum. Then I will do the same for the second turning points, which is negative 2.53, substitute it in the double differentiate function. And you get the answer negative 9.18, which is less than 0, which means that my x equal negative 2.53 is a maximum point, because it says here if the double differentiate value of the function less than 0, which is negative, mean that point that you've substituted is a maximum. So that's the answer for that question, and it's worth an excellence. Now the next question is you've been given a function for the profit, so that's the profit function here, where x represents the number of units that container sold. It says how many containers should be sold to maximize the profit. So that means they want the maximum x, that one here, and because it says maximum profit, so they want the maximum x. Maximum turning point, and then after that you will and what the profit will be, so they want the maximum profit. So there's two parts of the question. Because they were talking about maximum, the first step you will do is you differentiate your profit function. So you will say p dash to x, it's equal 250 minus 0.08x. Then you make it equal to 0, and then you solve it, and that gives you x is 3,125 unit. And because it's only one value of x, so we don't have to go on and prove this value is a maximum. It's only one value. Then you will find, so that's the first question. So that's the first part of the question. It says maximum x, that's the maximum x. And now you're going to find the maximum profit, which is substituting this x value into the main profit equation. Sorry, not x squared. Oops. And then if you substitute that, get your answer in the calculator, you get 390,925 is the maximum profit. Now next question. This one here says that you've got a container, you're making a box, the whole sheet that's been used 110 by 220, so it means the perimeter of the sheet is the width of the sheet is 110, and the width of the sheet is 220, and the height of the sheet is 110. Now the first thing is those corners, so you will they say calculate the maximum, so you go straight away and look into the question. The question says calculate the maximum of the volume of the box. So the box is gonna be just a rectangular prism. So the volume of the box, so the rule for that is the volume equal height times length times width. That's how you find the volume of rectangular prisms. Now because you can't really this is the neat of the box, so assume if you'd have to imagine it when you fold in the box, the height of the box will be this bit here. That will be your height of the box. Alright, so that's why you can write this bit here as h, give it as h. So I'm gonna mark this bit here, that line is an h, that red line. So this one will be h as well. All of these are equal, so all those little lines are h. Now the width of the box will be this line here, which is this one. That one here, that will be my width of the box when you fold it. And the length of the box will be this bit here. All right. So now you will, because I can't differentiate an equation that has 3 different variables, you will have to rewrite the length and the width in terms of each. Now the whole thing is 220. So which means that this bit here, okay, it's 110. The whole thing, like, you know, half it. So this bit is equal to that one. So this one here is 110. So the length of the box will be 110 minus h. So I'll write the equation. So the length of the box is 110 minus h. Okay, if you want to use the whole 220, then you will have length is 220 minus 2h. Then you can take 2 as a common factor, so it's the same thing. Now we will have to find the equation or the expressions for the width. Now this is the width of the box. The whole thing, the width of the whole sheet is 110. The width of the box will be 110 minus 2x's, because you notice that I've got a height in here and another height in here. So that's why the width of the box will be 110 minus 2h. Now I can rewrite my equation as 110 minus h for the length, 110 minus 2h for the width, and then h for the height. Now I've got an equation has only h as a common factor, as a variable. Then I will expand. So I'm not going to show you the expanding, you can do it yourself. So I'm just going to write the final expanding after I've simplified everything. Now the next step is you factorize, because it says find the maximum volume. So definitely I'll have to differentiate, not factorize, I have to differentiate the volume equation. So the volume equation differentiated. Now the next step is, because I'm finding the maximum, so I need to find the turning points, and finding the turning points I need to make the differentiation function equal to 0. Solve. So again you can use your calculators. So you get 2h. So the first value of h is 86.6. The second value of h is 23.25. Now because I've got 2 values of x, so I have to continue and work it out which one is my maximum value. Okay, and I will use the double differentiate function, or the double differentiate formula. So I will double differentiate this bit here. So second differentiation, which is negative 660 minus 12h. Now I will substitute in the double differentiate function the first h, and that's giving me negative 1699, which is less than 0, so it's a maximum. The second one, 23.25, it's negative, also it's a maximum. So well, you could have even without doing this, because the highest, the higher the h, then obviously this one becomes bigger L and bigger W. So the maximum, so I'll choose this one here as my maximum. Then I will find my volume for that. So just substituting the volume. So I will substitute in this equation here, the expanded and the simplified equation of the volume, instead of calculating length and width separately. So times 86.6 square minus 6 no 2, sorry, and 86.6 to the power of 3, and you get the answer as, well, so you get the answer as 128,075.1 centimeter cube, and that's the maximum volume. Okay, so the first thing, you will go straight away and read in the calculus questions, you read what's required in the question. It says find total surface area. So I would write the first thing, I would write the formula for the surface area of a cylinder, which is CA equal 2 pi RH for the body plus the lids, 2 lids, because it says here the top lid is part of it. Okay, now then I've got a formula. The formula that I need to differentiate, it has 2 variables, so they need to go back to the question and read to find a relationship between R and H, which is, says here the volume of the cylinder must be 1 meter cube. Then I need to go write the volume rules for the cylinder, which is pi r square h, make that equal to 1, rearrange 1 equal pi r square. Now I will substitute the value of h in my surface area and simplify. Now simplify, that goes this one with that, and then I got 2 over r equal, sorry, plus 2 pi r square. Now I can differentiate. So to differentiate that, remember the r is in the denominator, so I need to move to the numerator. That becomes r to the power of -1. Then that give me -2 over r square plus 4 pi r. Make it equal to 0 because I want to find minimum, so I need to find the turning points. Solve that one, that equation. I got, okay, so solve that equation, just rearrange, just got 4 pi r equal to over r squared, just taking that to the other side, cross multiply, it's 4 pi r cube equal 2, so r is the cubic root of 2 over 4 pi. Now you've got the r and it's one variable or one value. Now substituting that r in the surface area, again I'm not going to substitute it in that area when it's r and h. Remember, I've substituted, I've simplified, so I'm going to substitute that into that surface area equal 2 over r plus 2 pi r square. Substitute the r, you will end up with the surface area of 5.54 meter square. Okay, question 2. This time they're giving you the differentiated function of fx. So they're asking you to find fx. Because it's differentiated is being given, the derivative is being given, and you want to find fx, so you need to do antiderivative. So I'll integrate 9x squared minus 8x plus 5 with respect to x. So integrate mean opposite of differentiation, anti-differentiation. So instead of take a 1 from the power, we will add to the power. So we will have 9x to the power of 3 over 3, divide by the new power, minus 8x squared over 2, plus 5x, plus c, the constant differentiation. Now simplify. I end up with 3 x cubed minus 4x squared plus 5x plus c. That's not your differentiate, that's not the fx fully, because I still have c's unknown. So I'll use the second part of the information in the question, which lies on the point 220. So when x is 20, when x is 2, y is 20. So I'll substitute. So we'll substitute 220, and that give me 20 equal 3 open bracket 2 to the power of 3 minus 4 open bracket 2 square plus 5 times 2 plus c. Rearrange, you will end with c equal 2. So now I can write my fx equal 3x cubed minus 4x squared plus 5x plus 2. That's the final answer. Now next question is calculate the tangent of fx at this point. Now the tangent is basically you substitute 2 in the differentiate functions, and the differentiate function is already being given to you, so you will just calculate the gradient function is already being given to you because they give you the different derivative. Then substitute 2 in there. Okay, and that's give you 25. That's the gradient. Now they want the function of the gradient, so we will use y minus y1 equal mx minus x1. So y minus y is 20 equal 25, and x minus 2. Rearrange and simplify. You will end up with y equal 25 x minus 30. Okay, so the next question is finding the rate of change for this function from 0, x is equal to 0 to x equal to 2. So you need to find the y value first for each one of those. So when y equal 0 square minus 4, when x is 0, so y is equal negative 4. And y equal 2 square minus 4, so when x is equal to 2, y is equal to 0. Rate of change, it's like you're finding a gradient. So change in y over change in x. Which is give you negative 4 minus 0 over 0 minus 2. And the answer is negative 4 divided by negative 2. So the answer is 2. And that's the change. So there's no really any differentiation or other stuff. Now the next question is the car traveling in a fixed point. They give you the distance formula. So that's the distance question. And then t is measured in seconds, distance is measured in meter. Now it says calculus, use calculus, meaning you're going to differentiate when the car is at rest. So you need to find when the car is rest, and to determine when the car is at rest. So you need to find at what second the car is at rest, and calculate what the acceleration of the car at t equal to 4. So basically, because it says acceleration and car at rest, so you need to find the velocity. To find the function of the velocity, you're going to substitute differentiate the distance formula to get the velocity. So velocity equal negative 2t plus 6. So now when the car is at rest means t is equal to 0. If you substitute t is equal to 0 in here, you get the velocity is 6. Now it says calculate what velocity of the car at the t equal to 4 seconds. So which means at t is 4, so it's negative 2 times 4 plus 6, you get negative 2. Okay, so when t is 4, the velocity is negative 2. Alright, that's it. Seconds, meter per seconds. Next question is talking about a skyrocket. There's so many things to say. They said find the equation of the function. So that's the requirement is finding fx. Now we need to go back and see what information is being given. So the rocket's distance functions from the fixed point has a maximum turning points. So the distance function has a maximum turning points at x equal to 5 meter and a minimum turning points when x equal to 8 meter. The distance functions passes through the point where it has a gradient of negative 5. Now those two pieces of information, maximum and a minimum, means it's a quadratic. When you actually the derivative or the function itself is a quadratic, has two points, minimum and maximums. All right, the derivative of that. So means that you functions, if you write it as vectors, you will have x minus 8 and x minus 5, because when you make this the derivative function equal to 0, you will end up with x equal to 5 and x equal to 8. So you're kind of thinking backwards, but there could be a function, a scale factor for it. So you must do it multiplied by k, because we don't know if there is a scale factor for it or not, and that's what we're going to do when we substitute, when we use the other equations. Now the other piece of information says that the distance function passes through the point 10, 15 where it has a gradient of negative 5. Means the gradient value, which is the f dash, equal negative 5 when x is 10 and y is 15. So if I substitute instead of f dash, which is the gradient negative 5, substitute instead of x 10 minus 8 and 10 minus 5, solve all of that, I'll end up with k equal negative half. Now, so at the moment I found the k, so my derivative function is negative half k minus 8 and x minus 5. So I will expand. I end up with negative 0.5, expand and simplify, plus 6.5k minus 20. Now I need the function or the equation of the function of the distance functions. So that's why I will have to integrate or anti-differentiate. So anti-differentiate that, you will get add 1 to the power, divide by the new power. So you will get negative 1 out of 6x cubed plus 13 over 4x squared plus 20x plus c. That's my fx. Again, that's not the full function because c is still unknown. Now remember this piece of information, the function passes through 10, 15. So it means 10, 15 satisfy the equation of the function. So I'll substitute instead of fx15 instead of x10. To find the value of c. And under c is 56, 2 over 3. So my equation of the function is negative x to the power of 3 over 6 plus 13x squared over 4 plus 20x plus 56 2 over 3. You don't have to simplify it any further. Okay, this time I've been giving another skyrocket, but this time it's been giving the gradient function or the derivative functions. Give me 2 points that pass through the original function passes through those 2 points. Now because I've been giving the derivative functions, so the first thing that I will do is anti-differentiate with respect to x. So anti-differentiate that give me f to x equal negative mx squared over 2 plus 5x plus c. Now you notice that I've got 2 unknowns in here. That's why I've been given 2 equations. So I will substitute the first point that's given 2 points. So the first point is 8 equal negative m times 16, because 4 squared is 16 divided by 2 plus 20 plus c. Rearrange it so I have the unknowns in one side of the equation and the constants in the other side of the equation. So I end up with negative 12 equal c minus 8m. And I will do the same. That's when I've substituted for 8. Now I will substitute 10, 15. So it's 15 equal negative 100m, because 10 squared is 100 over 2 plus 5 times 10 is 50 plus c. That's 10, 15. And now rearrange exactly the same way. So that's my first equation. Then I'll do the second equation. And so it's 15 minus 50 is negative 35 equal negative 50m plus c. That's my second equation. Now using the simultaneous equations button in the calculator, that solving them simultaneously will give me c equal negative 7.62 and m equal 0.55. Now you found the c and m, then you can substitute it back into the main function because you want the main function. So which means f to x equal negative 0.55 x squared over 2 plus 5x minus 7.62, and that's my final answer. I don't have to simplify any further. Alright, so because you've been given the derivative functions and you want to find the main function, what you do when you have the main function and you want to find them, you want to draw the derivative functions, remember the minimum and maximum, we used to put them straight away into 0, which means those 2 points when x equal negative 2 and x equal to 4, they are minimum and maximum points, but you need to find out which one is maximum, which one is the minimum, or maybe both of them are maximum. We'll see. Now you need to look before negative 2. So you can see before negative 2, that line or the curve is above the x-axis. Mean the function was increasing before negative 2. So you can draw or you can mark your maximum, negative 2. It's increasing, so it means it's maximum point. So negative 2, you can do it anywhere in here, variations. So I'll just do it in here. That's negative 2, so it's increasing to negative 2. So it's increasing to negative 2. So I'm very bad at graphing. And then the bottom part, so you can see the curve or that curve in here, it's concaved up, mean that's decreasing, it's below the x-axis. Can you see how it's below the x-axis? Mean between 2, negative 2, and between the 4, which is here, the function was decreasing. So that means my 4 was a minimum. And then after the 4, you can see the function is the curve after the 4, it's above the x-axis. That's mean was decreasing. So that's why my curve looked like that. So again, if the first part, if you look into this one here, between the two, that will tell you that one of them is a maximum, the other one was a minimum, because the curve under the x-axis, so it was decreasing in between, right? And then before and after, that's above the x-axis, so it's been increasing, that's another one's above the x-axis. So that's kind of roughly how would you draw it. Now next one, find the antiderivative functions of this. So just need to find the antiderivative functions for that one here, and apply the antiderivative rules. So adding 1 to the power, divide by the new power. So you've got y equal 2 over 5. I'm not going to play with this now, so it's add 1 to the power, divide by the new power. I'll simplify later. So minus 3x to the power of 5 over 5 minus, this one here is x to the power of 4 in the denominator. So it becomes, if you think about it, this bit here, it's as 1 over 5, but that's x to the power of negative 4. So when you add 1 to the power and divide by the new power, which is negative 4 plus 1. So that's kind of, how I'm going to do it. So just integrating it separately so you can see what's happening. So negative 4 plus 1 is negative 3. So that's why you'll end up with x to the power of negative 3 over, and this is negative 3 times 5, so it's negative 15. Okay, now again, this is a negative power, so you need to return it to the denominator. So that's why the final derivative for this term in here, it's 15x to the power of 3, and it's a negative at the front. And so that's why I'm going to write it as 1 over, got negative in here, 15x to the power of 3 plus 17x plus c. You should not be forgetting this c, because you'll get, now you try to simplify. So that's 1, that's 3, that's it, that's no more simplification. So my final y is x to the power of 6 over, multiplying those twos give me 15, minus 3x to the power of 5 over 5, minus 1 over 15x to the power of 3, plus 17x plus c. That's the final answer. Now the next questions is they give you the velocity functions of a thing where t is measured in seconds. Find when the particle velocity is decreasing. So you want when the velocity is decreasing. Now to find the velocity is decreasing, mean you need to find is decelerating. So which is basically the speed. So you're decreasing the speed, so you're slowing down, so it's deaccelerating. So that's why you will differentiate, because the accelerations comes from differentiating the velocity functions. So you will you find v, wrong color, no, it's not changing yet, got it, v dash to t equal, now if you differentiate that, x t squared plus t minus 6. Now factorize, because we want to solve it, we want to find the turning points. When is it decreasing? Make it equal to 0. So let's give you t equal to 2, or t is equal to negative 3 seconds. So that's mean it's decreasing between negative 3 and 2 seconds. The particle velocity is decreasing. You have to communicate your answer at the end. Now next questions is saying find the particle, I think it's the last, no, we've got one more question. Okay, so find the particle accelerate at 1 second. Okay, so you've got already the acceleration functions because we've already found it out when we differentiated the velocity. So that's the one here. Now at 1 second, so t is 1, so a is equal 1 plus 1 minus 6. So a is equal -4 meter second square. Remember, that's acceleration, which means that's the movement or the object or the particle is slowing down, deaccelerating. So you could say deaccelerating or slowing down, so it depends on which words that you've used. Now the next question, or the last question. Now the last question is Air New Zealand. Okay, so Air New Zealand's been given that a main craft is running on normal conditions, 60 meter per second. The aircraft speed will be expected. Okay, I'll just go straight away to the question itself. So it says how far. So they want distance from the aircraft travel when it lands, run away when its speed is 10 meter per second. So they want distance. Okay, and they're giving you acceleration, which is -4 meter per second square. So they're giving you acceleration. So the first step is you need to find, remember the rules. We have distance, you differentiate, you get velocity, you differentiate, you get acceleration. Now we are here, so we need to anti-differentiate. So anti-differentiate that, so the velocity mean -4 with respect to t, obviously, plus c. So now you need to find the c value. So when that says it runs at the normal condition speed of 60 meter per second, so that's the piece of information, which means normal condition. So when t is 0, v is 60. So if you substitute that in here, give you c is 60, so your velocity is -4t plus 60. Now I need to find the distance because they say how far, so I will have to integrate again. So I'll get the distance formula by integrating that. So I've got -2t squared by adding 1 to the power 2 divided by 2, that's simplified to -2 plus 60 t plus c again. Remember, every time I integrate I have to put 0. So now when the distance is 0, so initially when the aircraft have not moved, so that's mean the distance of how from where it's land. Okay, when the distance is 0, the time is 0. So initially everything is 0. So that leads c is 0 because if you substitute everything. So the distance formula, -2t squared plus 60t plus c. By the way, it's quite important that you show this step here. So even if you know c is 0, you can't assume c is 0. So I'm not going to write it down. So I'm just going to take it off. There's no need to writing it down. When you have to say why is c 0. Okay, so you can't just assume and write t 0. Now the question says how far when it is 10 meter per seconds. Okay, when it's speed 10 meter per seconds. Now you need to find out what t is that, because I don't have speed in here. I have only the t as a variable. So I will use the velocity formula. Substitute in the velocity 10 and find t. So after you solve, rearrange, get t 12.5 seconds. Now I'm going to substitute that in the distance equation to find how far went. So you can see it's quite a multiple step, and that's why it's an excellent question. And you end up with 437.5 meter. So that's the distance.